Scientists have discovered a previously unknown way that some bacteria produce the chemical ethylene, a finding that could lead to new ways to produce plastics without using fossil fuels. The study, published today, August 27, 2020, in the journal Science, showed that the bacteria created ethylene gas as a byproduct of metabolizing sulfur, which they need to survive. But the process that the bacteria use to do that could make it very valuable in manufacturing, said Justin North, lead author of the study and a research scientist in microbiology at The Ohio State University. We may have cracked a major technological barrier to producing a large amount of ethylene gas that could replace fossil fuel sources in making plastics, North said. There's still a lot of work to do to develop these strains of bacteria to produce industrially significant quantities of ethylene gas. But this opens the door. Researchers from Ohio State worked on the study with colleagues from Colorado State University, Oak Ridge National Laboratory and the Pacific Northwest National Laboratory. Ethylene is widely used in the chemical industry to make nearly all plastics, North said. It is used more than any other organic compound in manufacturing. Currently, oil or natural gas are used to create ethylene. Other researchers have discovered bacteria that can also create the chemical, but there had been a technological barrier to using it, the need for oxygen as part of the process, said Robert Tabita, senior author of the study and professor of microbiology at Ohio State. Oxygen plus ethylene is explosive, and that is a major hurdle for using it in manufacturing, said Tabita, who is an Ohio eminent scholar. But the bacterial system we discovered to produce ethylene works without oxygen, and that gives us a significant technological advantage. The discovery was made in Tabita's lab at Ohio State when researchers were studying Rhodospirillum rubrum bacteria. They noticed that the bacteria were acquiring the sulfur they needed to grow from methylthioethanol. We were trying to understand how the bacteria were doing this, because there were no known chemical reactions for how this was occurring, North said. That was when he decided to see what gases the bacteria were producing, and discovered ethylene gas was among them. Working with colleagues from Colorado State and the two national labs, North, Tabita and other Ohio State colleagues were able to identify the previously unknown process that liberated the sulfur the bacteria needed, along with what North called the happy byproduct of ethylene. That wasn't all. The researchers also discovered the bacteria were using dimethyl sulfide to create methane, a potent greenhouse gas. All the research was done in the lab, so it remains to be seen exactly how common this process is in the environment, North said. But the researchers have identified one situation where this newly discovered process of ethylene production may have real-life consequences. Ethylene is an important natural plant hormone that, in the right amounts, is key to the growth and health of plants. But it is also harmful to plant growth in high quantities, said study co-author Kelly Wrighton, associate professor of soil and crop science at Colorado State University. This newly discovered pathway may shed light on many previously unexplained environmental phenomena, including the large amounts of ethylene that accumulates to inhibitory levels in waterlogged soils, causing extensive crop damage, Wrighton said. Added North, now that we know how it happens, we may be able to circumvent or treat these problems so that ethylene doesn't accumulate in soils when flooding occurs. Tabita said this research is the result of a happy accident. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.